I'd like to especially, thank you for organizing this session and ask you to kindly try to be very strict in respect of time today, especially because we have the final ceremony, the ending ceremony at midday sharp should be. So it's a bit unfortunate because in the other days we could go a bit further, right, after midday in Brazil. But today, they asked us to send this guideline, this general guideline.
Of course, we need to finish before 12 o'clock from Brazilian time, and we'll be there in the closing ceremony, of course. I need to check if all the presentators are here. You must sorry me if I can't pronunciate correctly your names. I am trying to do my best. Gabriela, Bastien, Rodolfo, Gültekin.
Yes.
Good morning. Oh, it's good morning for me. Good evening, certainly for you.
Yeah.
Larissa, Laura. Where is Joy? Elizabeth. Joy is here, joining the session. So hello, everybody. Very nice to see you again. Just to checklist for all the presentations. This is our session 10, shallow lakes in agricultural landscapes. Yesterday, we had 9 wonderful presentations about all the aspects related with the relationship between landscape, agricultural landscape, human activities in the landscape, and water quality and other aspects of shallow lakes ecosystem health. Today, we will have 9 more. I see it quickly. Joël Alain from the University of Lorraine in France. Biotic interactions shape the effect of combined stressors on shallow lake ecosystems, insights from microcosm experiments. I need that every one of you close your mic, please.
Yeah, I'd like to ask everybody to try to keep their mics off. Thank you.
Thank you. Thank you, Andros. Then Bastien Post, his work is Exposure Pathway Matters, a microcosm study to evidence effects in phototrophic communities by agricultural runoff, introduced via sediments or the water phase. He's from the Helmholtz Center of Environmental Research in Germany. Then the presentation of Rodolfo Pelinson, Assembly and Reassembly of Freshwater Communities under the influence of agrochemicals in different spatial contexts. He is from the Universidad de São Paulo, Brazil. Then we have a different work, wonderful work from Monica Pinardi. She works in the Optical Remote Sensing Water Group, Institute for Electromagnetic Sensing of the Environment in Italy. And the title is Assessment of Cover and Abundance of Primary Producers in a Shallow Eutrophic Lake in Agricultural Watershed using Hyperspectral Satellite Data. Then we move to Turkey with the work of Gültekin Yilmaz, Decadal Change in Size, Salinity, and Biodiversity in Lakes in Konya Closed Basin, Turkey, subject to climate change and increasing water abstraction for agriculture. He is from the Middle East Technical University, Mersin, Turkey. Then a homework from São Paulo State University in Brazil, Larissa Gonçalves Santos, which factors influence the occurrence of Caoborus larvae in neotropical shallow lakes? Then we have a presentation, Thais de Fátima Ramos Guimarães from the Universidad Federal de Rio Grande do Sul, effects of land use on fish richness on neotropical coastal lagoons. Unfortunately, Thais couldn't be join us in the session, so we will have this mention of the title. Maybe if you have questions, you can contact her, but she will be not here. So we jump to the work of Gabriela Ondandia from the Leibniz Center for Agricultural Landscape Research in Germany. The title is Key Drivers Structuring Rotifer Communities in Ponds, Insights from an Agricultural Landscape. And finally, closing this session, Maria Laura Sanchez show us drivers of planktonic chlorophyll A in Pampean shallow lakes, a regional approach. She is from the Institute of Ecology, Genetics and Evolution from the Buenos Aires University. So I say no more. Please, everybody with your microphones and cameras off when the videos, and then open it for the questions and answers. The final remarks, if we have time. I stop share and I give place to Joey Allen. Please, Joey. Great.
So you see my screen in presentation mode?
Wonderful.
Okay. Okay, perfect. So my talk was about biotic interaction that shape the effect of combined stressors on shore-like ecosystems. And I speak more specifically about the result of a multiple microcosm experiment. This is a part of the project Team Shift. You already see some part of the. You already heard about it yesterday, I think, with Elizabeth Gross' presentation, and you will heard just after Bastian's presentation on this project. And the thing is that we test the combined effect of two stressors, warming and agricultural runoff with a cocktail of nitrates and pesticides on shallow lake ecosystems that were simulated in this microcosm that contained phytoplankton, periphyton, macrophyte, and primary consumers. And in this system, I particularly try to disentangle what is done due to the direct effect of the different stressors and what is due to the indirect effect through competition or consumption by primary producers. And so the result, the main result of this experiment is represented here by this path analysis. Is that the temperature are not so much effect, but agricultural runoff have a strong effect on grazers that induce an indirect positive effect on periphyton. Additionally, it probably have also a direct positive effect on periphyton. And so this allows development of periphyton in the presence of this agricultural runoff led to a reduction of phytoplankton in the presence of agricultural runoff, while due to the nitrate, the direct effect of agricultural runoff will likely be more positive. And so this particularly highlights the importance to take into account this very indirect effect, this indirect network with here two players before going to the observed effect on phytoplankton. So now I think more information are on the video, and you can also have more information on this in the articles that gather most of the results I presented in this presentation, and I will send the link also maybe to the chat if someone wants to access it rapidly.
Thank you, Joey. Very, very nice. I love your microcosms. They are very, very wonderful. So small and with so many components. They work really, really good. So is there some question for Joey? I must confess that I checked the forum 8 hours ago. Now Andros is doing to know if there's a recent question there. I will join here. And Rodolfo, please.
Thank you. Thank you, Joey, for the presentation. It was really interesting. I was wondering, your agricultural runoff treatments, they all combined I think, nitrate, fungicides, insecticides, and herbicides, right? You did not have any treatments that only had different combinations of those pesticides, right?
Yeah, right. It's in some way we choose to use directly some combinations that might be representative of what arrived to shallow lakes, and testing separately each component with, we had four pesticides plus the nitrates. So separating each component will be just too much thing to do. We necessitate a high number of something like this.
Yeah, no, I had the same problem.
Perhaps we can amend here that during the project we had other experimental designs running with the same setting in principle, and there we also used factorial designs of the stressors and the chemicals itself. You can have a look to the other ClimShift presentations during this conference.
Oh, cool. Thank you.
Thank you. Another question?
Yes, I would have another question here.
Please, Marcus.
Thank you. And thanks to you, Joey, for this nice presentation and great experiment. I think it's indeed a lot of work behind it. But for your results part that you also presented now, I'm curious if you also took all the abiotic parameters into account for describing direct or indirect effects. Like, did you observe any changes there?
Yeah, there is changes. For instance, the interaction, the negative effect of periphyton and phytoplankton is likely mediated by phosphorus limitation.
Mm-hmm.
For the model and for simplicity, I could not add everything, and since it was in very controlled environment at the beginning, all the abiotic parameters were similar, except of course the temperature. That was one of the factors. But and so yes, there is change. These changes are mediated by in abiotic parameter, but this difference in abiotic parameter are due to the, are not true abiotic difference, they are due to the biotic activity.
All right. But did you observe like really big changes, for instance, in the oxygen content or pH or EC or so? And if yes, did you take that into account, like that changes in these parameters could maybe directly or indirectly affect your biotic components?
For oxygen, and we did not have very strong following of these parameter. We mostly focus on the nutrient and on the biotic component of the system. But yeah, it may have played a role.
Okay, all right. Yeah. I need to admit, I also didn't fully watch your presentation, but I will do. Thanks a lot. Thank you.
You're welcome.
The Clean Shift is a really great project. I enjoy all the works, how to cope one another and how to you search for a whole of the impacts and whole the relationships and the ways that they come to the aquatic organisms. It's a great project. So is there any more question for Joy? Thank you then, Joy. Thank you very much. And
Thanks.
I am calling for Bastien. Are you ready?
Yes, I am. So I'm sharing my screen.
Please.
So can you see my screen? Good.
Perfectly.
So, well, yeah, my experiment is basically a microcosm study where we tested 2 different exposure pathways of this agricultural runoff mixture that Shui was already introducing us to. So you can see here my microcosm, and we tested the exposure of this artificial runoff mixture via the water phase or the sediment. We were using 2 different concentrations of this mixture, and as well as 2 different temperatures, so 22 degrees and 26 degrees. And after 4 weeks, we sampled with a focus on the overall biomass. Basically summing it up, we could see that when the RO is exposed via the water, we got a high risk of regime shifts. So we got a lot of phytoplankton, we got only a few or kind of reduced macrophyte biomass. When we exposed the RO via the sediment, we actually expected less macrophytes due to the exposure and the potential higher uptake via the roots. This was not really the case, but we didn't see a phytoplankton development here, so there was not a lot of leakage of nutrients from the sediment. And we expected that the increased temperature increases the observed effects. So we expected a stronger regime shift, but actually this was not the case, as the higher temperature was benefiting our macrophytes and left our phytoplankton basically unaffected. Yeah.
Yep. And that's very, very interesting.
Thanks.
We have time for answers. If there is questions to Bastien.
So there was some question from Marcus on the forum. I mean, probably you just want to repeat them here, Marcus.
It's quite a lot. Maybe you just answer it in the platform, and then I do a really short or shorter questions here. I don't know. Maybe that's better because, yeah, indeed, it's a nice experiment. And I have 2 follow-up questions on it that might be more interesting for also the people here. I don't know. Yeah.
Yeah, go ahead.
If that's fine for you. Okay. Like, did you guys have the chance to measure the concentration of your RO in, for instance, the water phase, to assess the kinetics of your mixture?
Yes, we did measure the nitrate and the pesticide concentration, and it declined. So the pesticides roughly declined by 10% per week. The nitrate was almost completely gone at the end of the experiment. And so far, I also measured the pesticides within our sediment. So I sampled the pore water at the beginning and at the end of the experiment. And we could see that the decrease of the pesticides was really strong. So we got barely any pesticides left in the sediment at the end of the experiment.
Yeah, that's really interesting indeed. Yeah, yeah. And did you relate it, or could you relate it to a temperature effect? Like, did you see, for instance, higher degradation of your RO mixture in the 26 degrees treatments compared to control, or to the lower ones?
So far, I couldn't see a temperature effect. No, probably the time scale is a little bit too low. It's 4 weeks. So I think if you would extend the time, you could probably see an effect.
All right. Yeah. Because I think you didn't show anything in the presentation, right? About the
that's right.
So, okay. All right.
I just finished the analysis after uploading the video.
Yeah. No, it's all fine. Okay. Then I didn't miss something. Okay. And my last question would be, like, would you expect like similar results for your macrophyte and phytoplankton observation if you would exclude the nitrate in your RO?
Well, I certainly would not expect that strong phytoplankton development. And regarding the macrophytes, we tested in another study that was presented by Mechthild in this conference. We tested like only the pesticides, and we could see that the for example, the herbicide alone can have a positive effect on selected macrophyte species. So that's really difficult, as it seems to be species depending. And also concentration depending.
Yeah. Okay, thanks a lot, Bastian.
Yeah, thanks for your questions.
Yeah, thanks.
I have a question. I don't know, I can't see all the faces because Bastian, can you leave the share screen so
sure.
I can see more faces and see if is there any more question? I want to ask you then, your sediments are mostly clay?
It's a mixture based on the OECD protocol for the Myriophyllum spicatum sediment contact test. So it's some nettle powder, quartz sand, kaolin, so basically a clay mineral mostly, and some peat. Yeah.
Okay.
We got some organic material in the sediment, but we expected a high absorption of our pesticides by, for example, clay particles.
Okay, that was I thinking about in the absorption of different sources of nitrogen or other components, even the agrochemicals that in water divide the molecule, and you have chance to be retained in the sediments or not, depending on the oxidation or the
exactly.
Yeah, but you took that into account.
Yeah. So we were discussing this.
Okay, because one of the most important things in the project as a whole is to be realistic with the context, with the impact components, and that I think that is important to have the nature of the sediments into account too.
For sure. I mean, would be quite interesting to test it with some actual sediments you take from the field. Yeah, but this is, at least for now, beyond the scope of our project.
Maybe next presentation we have some.
Next year then.
Yeah.
Great.
Okay.
Thanks
you
for
very
all your
much.
questions.
Thank you, and I welcome then Rodolfo. It's your turn. Please share your screen and we listen to you.
Okay, thank you. I'm gonna share my screen here. Just a moment. There it is. Can you see it?
Yes, perfectly.
Okay, so here we did a field experiment because we wanted to know if spatial isolation of ponds would change the effects of agrochemical use on insect and amphibian metacommunity structure. So what we did was we made a field experiment when we had different treatments of isolation from a source of colonizers. So this was a floodplain of a stream. And we had the three isolation treatments were at 30 meters, 120 meters, and 480 meters from the source. And each of these transects of ponds, we had 5 control ponds, 5 pasture ponds, and 5 sugarcane ponds. Pasture ponds were treated with fertilizers similar to what is used in sugarcane fields. And the sugarcane ponds were treated with fertilizers, herbicides, and insecticides similar to what is used in sugarcane ponds, in sugarcane fields actually. So we tried to simulate what a crop cycle, what happens in a sugarcane field. So the harvest happens in the beginning of the rainy season. And so we filled our artificial ponds with water in the beginning of the rainy season. And then we added insecticides and fertilizers when the harvest is supposed to happen. And we also added a herbicide when people usually add these herbicides in sugarcane fields. And we made different surveys across time during the rainy season. And just to summarize our results, we did not find that spatial isolation changed the effects of agrochemicals. And we found that predatory insects exhibit very idiosyncratic responses to isolation. We found that herbivores and detritivores, they are usually positively affected by isolation, with exception for the end of the rainy season, when they are already less abundant. And we found that aquatic insects were strongly reduced by insecticide application, as we would expect, and that amphibians are indirectly positively affected by the insecticide because it basically kills their predators and competitors. And we did not find any apparent effects of the herbicide that we used. And this is some news from the presentation. After that presentation, we reanalyzed some of our data. Now, looking at the total abundance of predatory insects, so just adding everything up, and we found that in the middle of the rainy season, we see some patterns of increase in the abundance of predatory insects in our pasture treatments, which was when we only used fertilizers. This is something new from the presentation. And I think this is it. I would be happy to answer any questions.
Hi, I have a question for Rodolfo. First of all, I'd like to congratulate for the nice setting, experimental setting. Of course, the other experiments were also very cool, but this is closer to what I do. So that's why I perhaps liked it even more. My question is, okay, you didn't find a very strong signal of dispersal limitation, right? But this, of course, doesn't mean that the dispersal limitation is not very important, as has been shown by other studies. So I was wondering whether this most extreme scenario of 480 meters is actually within the dispersal capacity of most species, And secondly, whether or not there might be other like different source of colonizers that were not taken into account, because this unfortunately sometimes happens. Although we focus on what we think is the source, might be there are some stepping stones or other lakes in the surroundings. But anyways, yeah, the remaining results are actually striking and even more important, right, for the effects of pesticides and so on. So yeah, I just have these two questions on dispersal limitation. Thanks.
Okay, thank you, Andros. First question is about if we think that 480 meters is enough to cause an effect, right? So we are not we don't really know how far each of the insects we had in our experiment could disperse. I am kind of confident that all of them can reach our most isolated treatments. What we think is that they would not reach that treatment as frequently as they would reach the less isolated ones. So we would see a lower abundance in more isolated treatments. And for that, we did find some works on aquatic beetles and dragonflies that show that not actually the dragonflies, that especially for aquatic beetles, show that a distance of 100 meters is enough to cause significant change in abundances. So that's why we chose those distances. And another reason to choose that distance, I think you can see my screen here, right? This is the area where we did the experiment. So our ponds were set up right here, where my pointer is, okay. and we made sure that there wasn't any other aquatic source that was more than, I think, 600 meters from our most isolated treatments. So, this you can actually see our ponds here, are those little black dots here on the landscape. This was the floodplain that I mentioned. And if you zoom out here, you will see that there are other floodplains like that, but they are a lot more distant from this was our most isolated treatments. You can see the array of ponds here.
Okay, so in this case, excuse me, to what would you attribute this no effect, no strong signal of dispersal limitation?
Well,
so why?
Yeah, sorry, go ahead.
No, it's this. Why do you think this might be the case in your experiment?
Well, two things. First, the most important predators we had in our system were dragonflies. And these dragonflies, we know they disperse like really far, like kilometers. So for those specific kinds of insects, we don't think our isolation treatments actually work. Yet we did see some negative effects on some species of dragonflies. And that means to us that indirect effects are very important. I mean, some species are dispersal limited, some of them are not, and they are interacting with each other, and that can create a signal of differences in abundances in different isolation distances. So these patterns are actually pretty difficult to interpret. And we're kind of trying our best. So we see that some insects decrease in abundance, some of them increase, some of them have no effect. So there are clearly some indirect effects, some species interactions effects going on there, but it's hard to measure just by looking at abundances which were the ones that were actually dispersal limited.
Yeah, that's very interesting, actually. So you have a dispersal-mediated interaction network or something like that. So yeah, I finished my questions here to give chance for others to ask. Thank you very much, Rodolfo.
Thank you for the questions.
Okay, is there any other question?
I've got another question, please.
Please, Bastian, very briefly, because we need to move on.
Move on. Yeah, I wonder whether you tested or analyzed your chemicals and the kind of real exposure in your ponds over time.
You mean if we measured our insecticides and fertilizer concentration?
Whether it's kind of a really chronic long-term exposure or just some short-term acute exposure scenario?
Yeah, in the case of the fertilizers, we made weekly additions. We tried to simulate like a dissolution of the fertilizers in water the best we could, but it was the concentration, how it would dissolve was more of an educated guess than a very we did not found any references to that. The herbicide and insecticides, we just made like one single pulse, just in the same concentration that we would find in natural ponds in those places. We did measure the concentration of the insecticide and herbicide over time. And just a moment, you can show it here to you. This is the concentration of the insecticide. And you can see that it quickly disappears. It basically disappeared by the end of the experiment. And the herbicide, we could detect it, but we could not quantify it. So it also almost disappeared by the end of the experiment.
Okay, thanks.
Thank you.
Thank Rodolfo. I ask you to leave your screen. To make place to Monica. Are you ready, Monica, to share your screen?
Yes.
Please.
Can you see my screen?
Perfectly.
Okay, thank you. I try to put in presentation mode. Good morning to everybody. And I'm Monica Pinardi, and I would like to show you in this picture all my colleagues of the remote sensing water group. I'm also guest editor together with other colleagues of a special issue on study of lake primary producers and water quality using remote sensing technique of Water Journal, and where you are welcome. So, remote sensing data are a useful tool for monitoring water quality and primary producers in freshwater ecosystem at different spatial and temporal scale. Phytoplankton, for example, may be described on the basis of biomass or their function, macrophyte by morphofunctional parameters such as biomass or density. A focus of remote sensing application is currently on cyanobacteria species dominated by phycoerythrin and phycocyanin pigments, exploiting hyperspectral data. For this reason, the main aim of this work is to investigate the capabilities of hyperspectral data compared to multispectral one for assessing primary producers' composition, abundance, and distribution in a shallow eutrophic fluvial lake exploited by intensive agriculture and livestock farming. The study area are the Mantua Lakes, located in northern Italy. And the Mantua Lakes are a shallow eutrophic system dominated by phytoplankton and native and alien macrophytes. The watershed is characterized by heavy exploitation by human activities such as agriculture, tourism, and livestock farming. The main outcome of this work is reported in this slide. I try to do that. So we can see the spectral signature of water that we can consider as the fingerprint of water. The spectral signature was measured by spectral radiometer in situ, that is the first graph. And it was compared with the signature measured by satellite, both multispectral one, as Sentinel-2 and Sentinel-3, and hyperspectral one, DESIS and PRISMA. It is evident that the hyperspectral measures compare better with the in situ data. For this reason, we retrieved chlorophyll A and phycosanin concentration maps for the Mantua lakes. I reported here an example for the end of June by DESIS mission. And we can see that where we have the maximum of chlorophyll A correspond to the maximum of phycosanin, which is the main pigment of one of the main pigment of cyanobacteria. We also retrieved a map of above water biomass of macrophytes that colonize these shallow lakes. And in particular, we can see, for example, that the alien species, the lotus flower, has a higher biomass compared to the native water chestnut. Sum up, we can say that small lakes need monitoring due to a general observed increase in eutrophication and the spread of cyanobacteria and invasive macrophytes. The preliminary results shown in this work reported a great advantage in the use of hyperspectral data to characterize primary producer and to support monitoring and management of aquatic habitats. Hyperspectral remote sensing provide the adequate spectral resolution to detect cyanobacterial bloom that can potentially produce toxins. Macrophyte products are also useful for water management and to control invasive species to guarantee conservation purposes. And, thanks, Maria, for this few time that you give me, because I would like to say to all of you that we are participating to this Lake CCI project under the Climate Change Initiative founded by the European Space Agency. And the main objective of this project is to produce and validate a consistent data set of the lake variables by combining different satellite observation to produce long time series. The lake variables are water level, extent, surface temperature, ice cover, and water color. That is, for example, chlorophyll A concentration or turbidity. Currently, the first version of the dataset was produced and is available for free. Now in the map, I show actually the about 250 lakes for which all of part of these variables are available for the community. If you have some question about this, you can contact me or ask directly. Thank you.
Oh, thank you, Monica, for your presentation, your wonderful project and your wonderful tool.
Thank you.
I know that is a question from Maria Laura in the forum about...
I read the question of Maria Laura, and if you want, I can answer here also. Yes, it is possible to retrieve submerged vegetation, but we need obviously clear state water with a bathymetry in the range between 0 and 10 meters, but for sure. Okay.
Thank you, Monica, because I was trying to do that with shallow lakes, less than 4 meters, and with clear waters, but with multispectral images, and I couldn't see the submerged macrophytes. So I will contact you, and I saw you answer. So thank you very much.
You're welcome. So we can keep in touch. Thank you. And okay.
There is a question also from Alejandro Lopez here in the chat. Congratulations, Monica. You have currently a situation of Nelumbo invasion on your lake. What is the origin?
Thank you, Ale. Yes, it's not a recent invasion because the Mantua lakes started to be colonized by Nelumbo nucifera in 1920 by a botanist from my city, Parma, that imported these seeds into the lakes for food reason. But obviously in the last 25 years, the Nelumbo spread a lot into the lakes, and in the Superior Lake, that is the first, that is the lake at the beginning of the system, more or less more than 30% of the surface was covered by this invasive species. And since the end of 90s, the Mincio River Park tried to control this invasion, but but we have not yet obtained a solution. Okay, and so this is why we have this widespread of this species, and the lakes along the decades become more eutrophic due to the pressure on the watershed, and this is why we have the possibility to have the coexistence of both phytoplankton and invasive species that are floating species or emergent species. And more recently, in the last 3 or 4 years, also Ludwigia hexapetala spread a lot into the system. And this is the new criticism of our lakes.
Marcus, you start your camera. I think that you have a question.
Yeah, thanks, Monica, for this nice talk and nice presentation. It's really interesting. And it's more a question out of curiosity. Like, can you use already existing time series data maybe to predict like which lakes might be close to collapsing, to prevent it even, you know, like to see, okay, it's still in a state where we can kind of prevent the total destruction. Yeah.
Okay.
Like can you do this predictional work already? Is there enough knowledge on that?
I started to study this system since 2004 during my thesis and then doctorate. So I studied before the system on a biochemical point of view, and I did mass balances of nutrient and chlorophyll and so on. So we started to know the system from this point of view. And then in the last 5-6 years, I integrated this data with remote sensing data. So I studied the evolution of the macrophyte stand in the last 40 years, and I published a work on this. And for this, I can say how these stands evolved during time. And I try to understand why, for example, lotus flower spread in the upstream portion of the system, closing the water flow, the water passage to the system. We can try to identify the area where it is more probable to have, for example, the spreading of the vegetation, the aquatic vegetation. And we can try to, and we did that, to identify the area where it is more probable to have high concentration of chlorophyll A. So we recognized the area where there is stagnation. So the accumulation of phytoplankton is more probable during a period of stable weather, high temperature, so in summer. And so we have different object of warming that can be taken into account to prevent the risk of hypoxia and anoxia, because in 2007 we had this risk, and more than 30% of the volume of the Middle Lake, this is the second lake, were under hypoxia condition. And so we asked to the water managers to open the dam and have a more flow, a more water flow to cleaning the lake. So we can try to help water managers to manage the system to avoid this disaster. Okay.
Yeah. Very informative. Thank you.
Thank you.
Oh, so thank you, Monica.
You're welcome.
And I give place now to you, Tekin Yilmaz.
Yes. Well, hello, everyone. Should I share my screen?
Please.
Hello, everyone. Should I start right away? Do you hear me now? Hello?
Yes, we can hear you.
Okay. Yeah. Okay, sorry. Hello, everyone. Today, I am going to talk about our recently submitted research. It is more like a review or synthesis paper, if you will. And we are going to, evaluated the recent changes in the last 30 to 50 years that happened in Konya Coast Basin, a very important economic and biodiversity zone in Turkey, which is under the increased water abstraction, human activities, and also climate change. And for this purpose, we conducted trend analysis on meteorological observations about precipitation and evapotranspiration. And from the available literature data, we evaluated the land use change in terms of agricultural output and also groundwater levels. And also, we derived the salinity index from satellite imagery and calibrated it with ground truth data in order to document the past changes. And we also, again, from the literature, accounted for the biodiversity loss in terms of fish and water birds. And we also make some future projections about the region. The region is a very big and biggest endorheic basin of Turkey. It houses extensive agricultural activities that heavily depends on irrigation because it's a semi-arid region, and it is also a very important biodiversity region. But as you see, the trend analysis showed that although there are no clear trend in the precipitation in the last 50 years, we can say that the annual temperature is steadily increasing in the last 50 years, which in turn increases evapotranspiration, the surface evaporation. But more important than that, there are enormous agricultural land use change that happened in the last 20 years in the region. It is a heavily irrigated area, and the water demand in the basin almost doubled in the last 20 years because the water-intensive crops such as sugar beet and maize are increasing their share, and also because of they are incentivized by the government due to their economic value. And they almost comprise the 50% of total agricultural output right at the moment. But where does this water come from? It comes from the irrigation reservoirs and also groundwater sources. And the deficit is provided by transfer from neighboring catchments by mega projects, so-called mega projects, that divert water from the other regions of Turkey. And almost of the 90,000 wells in the basin, more than 40% are unlicensed. They are overlooked because that's because of their it's a gap in policy, I believe. And due to this fact, in the last 30 years, the water table has dropped almost 30 meters. You can see it here. In the most of the wells, the groundwater levels has decreased dramatically and univocally almost. And this in turn results the receding of the lakes. The lakes are drying out in the basin. It's a general trend. They lost their surface areas, and also in parallel to this, salinization also becomes a problem in these lakes because of the concentration of the ions. And here you see the salinity index results for the two lakes in the region. And this in turn causes the ecosystem degradation and loss of species due to the habitat losses and the ecosystem services. Globally threatened waterways are extinct in the region, almost. Here you see the sizes of breeding populations of 3 of these species. And also the species richness of waterbirds are also declining in general. Almost 15 species has been lost in the region in the last 20 years. Also, the endemic fish population are facing extinction because of the reducing habitats. And we also lost some of our iconic lakes like Lake Mekemar, which has been dried out in the last 10 years or so. And the Lake Beyşehir, we run some future projections depending on different scenarios. The Beyşehir is the biggest freshwater lake of Turkey that is also found in Konya Closed Basin. And regardless of our scenarios, if the current outflow regime is sustained, the lake is facing complete dry out in a couple of decades. And so the agriculture rather than climate is the key factor behind the change in the region, and the biodiversity loss is almost always resulting from the irrigation in the region. And that is the end of my presentation. Thank you.
No, thank you, Tekin, very, very much. I need to make a balance between all the presentations that are wonderful and very interesting and the time that we have that flies and we must finish at 12 from Brazil. So please, the questions for Tekin, I will read the first one here in the chat. What are water managers saying about it? Any conservation plan or a potential change in agricultural practices? This question is from, oh, sorry.
Please let finish the question. Actually, this is the lack of policy about what to do is the main problem, because as I said, the unlicensed wells are like the backbone of irrigation in most cases, and the governments are usually overlook this situation because they don't want to antagonize the farmers and producers. But it is not a sustainable mode of production in that case. That is the disastrous future why the Konya Closed Basin is in danger.
Okay, just a second. In connection to what Maria said, I just would like to recommend everybody to perhaps skip methodological details. So just give a very brief summary on the main hypothesis, introduction, and then jump to main results and conclusions, because the rest people already saw, or they can do it later on in the videos. Thanks.
What you say, Tekin, about the needs of development, the agricultural activities, and so many countries that need the money that they give and the food that they produce. So it is a complex horizon in the future, isn't?
Yeah, actually, the sugar beet and maize are the money crops, as you say, and the transformation began at the 2000s, at the beginning of 2000s, by passing of some sugar law, and it is incentivized, but there is no concern, at least obvious or apparent concern in the sustainability of this mode of production, because the water table is decreasing 1 meter per year constantly for the last 30 years.
It's a very worrying scenario for future. We will follow your efforts.
Thank you very much.
No, thank you.
Sorry if my presentation took so long. I didn't aware of that.
No, it's fine. Please leave the screen, and I will give place then to Larissa Gonçalves.
Hi.
Hi, Larissa. We are listening to you. Please leave the screen, Tekin.
Sorry,
I don't know if Andros... Then.
Okay. Do you see the presentation?
In a moment, yes. Now we can see you and listen.
So before I start, I would like to warn you that I don't have an English domain. And if possible, I would like to ask you send the question by chat or speak slowly. Sorry. Thank you. So my name is Larissa, and this work is a small part of my PhD entitled Which Factors Influence the Occurrence of Calborus larvae in Eutrophical shallow lakes. The aim of this study was to determine whether factors such as land use, limnological variables, and the presence of fish influence the occurrence of Calborus larvae. According to the results, we observed that all of these factors directly and indirectly influence the occurrence of Calborus larvae. Depredation by planktivorous fish and the other opportunistic juveniles directly influence the occurrence of the larvae, decreasing their abundance. Limnological variables were the second that indirectly influenced the occurrence of the larvae, where it was possible to observe in the canonical correspondence analysis that the variables chlorophyll, temperature, depth, and the pH correlate with the presence of Calboros larvae. On the other land use, had a low influence on the abundance of Calborids, possibly because it is a factor that depends a lot on the scale and the intensity of its sections. However, we can eliminate other types of interactions that can influence the occurrence of this diptera in different ways. Thank you for your attention.
No, thank you, Larissa, for your presentation and to accept the need to be brief. Is there some questions to Larissa? I see one here in the chat from Rodolfo. Larissa, I saw your video, great presentation, thank you. How many lakes did you have in each of your land use categories? I ask this because the length of your bar points out of a strong effect, but you did not find any statistical difference.
Yes, I collected in 13 lakes, shallow lakes. Não sei se eu respondi. But use the buffer, the 1 kilometer, the statistical.
Rodolfo?
Sorry, can I just make a small complement to the question in Portuguese? It's just a follow-up. Larissa, quantos lagos por categoria de uso da terra? Desculpa. I just asked how many lakes in each category.
Então, eu posso falar em português? Nós coletamos em 13 lagos e todos esses 13 lagos foram categorizados e essas categorias elas foram feitas de acordo com floresta, uso do solo, assim, como floresta ao redor, pastagem e também uso urbano.
Sim, mas quantos lagos tinham, por exemplo, que você categorizou como pasto, como uso urbano?
Ah, ok. Nossa, agora não vou conseguir acho que foi 3 ou 4 como pasto. De 3 a 4, isso. 3 or 4.
Thank you. Thank you. Yeah, I was just asking how many lakes per category. She said 3 or 4. That was just it. Sorry.
Yeah.
Yes, the answer was made in English first, but it is just to make easy the answer. Is there any more question? I agree with Rodolfo that you have a very interesting set of data. We discussed that in my teamwork also. You have a very, very interesting set. I think that maybe the statistical method is not optimal for your analysis. Maybe single relationships, single correlations will be better because you have a very limited set, but very interesting in the results.
Okay.
Well, thank you, Larissa. Next presentation would be that of Thais, but she can't be here. She has some problems, some schedule problems with the home office, the time of the day, and so if you have any question for her, you can email. And I will then go place to Gabriela Onandia. Please, if you can share your screen.
Can you see it properly?
Yes.
Okay. Yeah. Hello, everyone. Thanks, Maria, for the introduction. Our work focuses on identifying the factors structuring rotifer communities in ponds that are located in an agricultural area. So for this study, we selected a set of 42 ponds located in 3 land use types: arable fields, grasslands, and forests, in an area of around 200 square kilometers. And these ponds are of glacial origin, similar to the potholes of North America that you are maybe more familiar with. And here they are locally known as kettle holes. So moving to the results, we perform a variation partitioning analysis to check the role of space versus environment, and found that in spring, the environment was the most important factor explaining the variance in our data set. But this environment became less important in autumn, and the unexplained variance was the biggest part of it, while the explained variance by space remained low during both sampling campaigns. So we think that this indicates that in spring, habitat filtering is more important, and probably in autumn, biotic interactions take over, and dispersal is probably not limited in our study area, which is relatively small. So zooming in into the effect of environmental factors, we ran an isomap analysis to identify prevalent biogeochemical processes in the ponds, and found that the most important processes were fertilizer-driven salinization and primary production. And the score of these components were lower in forest ponds compared to arable fields or grasslands. And when we check the effect of these processes on the rotifer communities, we found that fertilizer-driven salinization and phytoplankton biomass decrease alpha diversity, but increase beta diversity or dissimilarity between ponds. But when we check at the biodiversity estimates across land use categories, we didn't find any significant difference. So we think that the widespread eutrophication, or the effects of the long-term eutrophication in the study area, as we can see, for example, total phosphorus is the same across land use categories, masks any direct effect of land use on the communities. So that's a very short summary. Thanks for listening, and I'll be happy to take any question.
Thank you, Gabriela.
I'm trying to stop sharing. Yeah, that's it.
Is there any question for Gabriela? Please, Maria Laura.
Hi, Gabriela. Very nice study. I have a question. Do you have data from other communities, other biological communities?
Yes, we do have data. We have data on the mesozooplankton fraction as well that we haven't analyzed yet. And we also sample macroinvertebrate communities. And there is a complementary study also on eDNA from bacterial to bigger groups. So, but we are on our way to process all this data. This is part of a project called Bridging in Biodiversity Science, and different colleagues focus on different groups.
Oh, okay, yes, because maybe other groups show other response to the same sampling design, no?
Yes, yes, actually, I mean, at least for example, for bacteria, we found, or it seems like there is an homogenization effect because agriculture. So also in the case of bacteria, for example, there were no clear differences with land use types, as in the case of rotifers. Yeah. But we did found an indirect effect through fertilizers somehow, if it was not clearly linked to the land use categories, but still we can see this negative effect.
Okay, thank you very much.
Thank you.
We have here in the chat a question formulated by Alejandro. Hi, Gabriela. These ponds are fishless?
Yes, they are. I didn't say that because it was very short time, but most of them are temporary. We have from a few permanent ponds, and most of them are temporary, and they are all fishless. So we had to exclude 2 ponds because there was artificial fish stock in 2 of the permanent ponds. But yeah, the ones we consider are fishless. Yeah, and most of the ponds in this area are fishless too because of the temporary nature.
Okay. Any more questions? Then thank you very much, Gabriela, for your very nice presentation.
Thank you.
Last one, closing our session, is Maria Laura Sanchez. Are you sharing your screen, Maria Laura? Open your mic, please. Open your mic, Maria Laura, please.
Sorry. Can you see the screen?
Yes.
Okay. Well, I'm going to present this collaboratory study that we perform among different laboratories from Argentina, from the Universidad del Noroeste, the Universidad de Buenos Aires, INTECH, and the Michigan State University. So we want to ask the question that what are the main drivers of phytoplankton biomass in Pampean shallow lakes? Because we find that there are no linear relation in a set of shallow lakes between chlorophyll A and total phosphorus. So we work with a data set of 60 shallow lakes belonging to different regions of the Pampean plain. The region is a very productive region that was described for different colleagues yesterday in different presentations. And we perform a linear mixed model with variables belonging to different groups, like physical and chemical data that we collect from the field, morphometry data that we took from GIS, and land use, and other different kind of variables. So summarizing the main results, we find that taking into account the whole data set, the 60 shallow lakes, the best fitted model include the total phosphorus macrophytes and the percentage of agriculture and the region membership that each lake belongs. So we find that submerged macrophytes model the effect of total phosphorus on chlorophyll A, and that the agriculture percentage in the buffer area of each lake exert a significant and positive effect on chlorophyll A. And also we include the region membership as a random effect or random factor, sorry, and we found that explained around 30% of the variance. So we decided to split up the data set in two, shallow lakes with submerged macrophyte and shallow lakes without submerged macrophyte. And we find that the best fitted model for the data set with submerged macrophyte was explained by a positive relation with the total phosphorus. However, for the subset of lakes without submerged macrophyte, we find that the best fitted model was explained with, for a negative relation with total phosphorus and lake area. However, the coefficient of both variables were very small. So in conclusion, for these Pampean shallow lakes, the relationship between total phosphorus and chlorophyll A was non-linear, and in most of these lakes, total phosphorus was not limiting for the algal growth, and the presence of submerged macrophyte is a key factor modulating the relationship between chlorophyll A and total phosphorus, probably stabilizing a clear regime. And the regional approach allows us to have an overview of what are the main drivers of planktonic chlorophyll A in these Pampean shallow lakes, and mainly due to the presence of submerged macrophytes. So thank you very much. And if you have
I have a question. Yeah. So I have a question. I normally look from the other perspective, so from the zooplankton perspective. So I was a bit surprised that you didn't include this variable, which is very close to my heart. So how much do you think you could improve your models by considering, I don't know, zooplankton grazing traits or biomass, whatever, like different diversity or so of zooplankton?
Yes, yes, it's true. Well, it is a work in progress, so I choose to include only like bottom-up variables, but it should be very interesting to include like predators for phytoplankton in this region. But well, we have some data because these data belong to different projects that were carried out for other purposes. So I need to homogenize the data, and some data have the zooplankton, but other we don't have the zooplankton information. So I need to look into the data again. Maybe I can include some predator pressure or like something like this. Very interesting. Thank you.
Yeah, or perhaps as a follow-up project could be like a small grazing experiment in those different lakes. So in situ experiments in which you inoculate like in small bottles the zooplankton to see the grazing pressure there and try to correlate in the next step. So you don't need to go to all those lakes, but perhaps get just a subset of them and do a small experiment to see if it's correlated or not. This grazing pressure, I mean, with the chlorophyll. So, but very interesting study, and thank you for the answers.
Thank you. It's a question in the chat.
Yes, I just say before to Andros that the power of bottom-up forces in the Pampean lakes is incredible. And the grazers do their best, but the power of the bottom-up force is really really strong. Yes, now the question of Alejandro here in the chat, please, Maria Laura. Congratulations. My question is, so you didn't find any significant driver related to the inorganic turbid state?
Yeah, no, because I didn't mention in the summarize, but we have we detect in the region that there are a third type of lake that is turbid, but with very low abundance of phytoplankton. The turbidity is due to high amounts of inorganic suspended solid. However, in our data set, we have a very small number of turbid inorganic lakes, so I couldn't differentiate the turbid inorganic with the turbid phytoplankton lakes with this data set. So maybe I think that we can add more shallow lakes, more data from other shallow lakes to improve the model and to go deep in these kind of drivers. What about correlation between, sorry, Maria? I can read the next question is about.
Okay, yeah, so Armando wants to know, he says, congratulations, Maria. Did you try logarithmic scale relationship between chlorophyll A and total phosphorus? So if you transform to log, so can you?
No, I think that I didn't, or I don't know, I didn't try. I can try. How the thing is that we have a lot of lakes with well, we have lakes with high concentration of phosphorus and low concentration of chlorophyll A. So I think that this is because the relation is not perfectly or is not linear. But yes, I can't try the log-log relationship. And there are another question before. What about correlation between total phosphorus and macrophyte? Unfortunately, I don't have the quantitative cover of macrophyte because this is submerged macrophyte, and we only have I didn't show in the summarize, but some of the variables are qualitative or categorical, and the macrophyte is what is present or not. No, we don't have the quantification. Because of that, I asked to Monica Pinardi to have a new tool to quantify the submerged macrophyte in this kind of lakes that are clear, but well, unfortunately from the field data, we don't have the quantification.
Any more questions? Thank you for your nice job, Laura.
Maria.
So I have just a couple of minutes for a final remarks. Can you see me here? These sessions was very, very wonderful. Thank of the presentations that we have. It's all your job that made this a great session. I think that we, in our 18 works, we have so many activities and factors that thread shallow lakes, and on the other hand, we have some targets or objectives for sustain an ecosystem health. In the middle, there is our job: field survey, remote sensing. We see different approaches, experimental, empirical, with new tools as hyperspectring or lake and watershed models. And we are doing very good our job. I think that we need more communication with managers, with farmers to achieve our objectives, because this is our context. Our context is that we have 8 billion persons in the world that need to be fed, and we must cope with that. And remember what are the most important tools of the science. This one: to think, to relate, to understand, to imagine, to view, and we must work with all that. Then we arrive at the end. Thank you all the presentators. And we close this session, and we can go to the closing ceremony of the Congress, of this wonderful Congress that made Coca and his team. So I sum myself with the applauses for all you. Thank you very much. See you in the closing ceremony.
Yes, thank you very much, Maria, for organizing this nice session.
My pleasure.
Beautiful one, nice topics. Thanks everybody for their contributions, right? Beautiful work as well. And I have just pasted the link for this closing ceremony, so you can find here in the chat in case you were a bit lost. So thank you very much, and see you in the other room. Bye-bye.
Bye.